In our last video, we talked about some of the key components of AI agents. You can check out the video here. In this video, we'll dive into the different types of AI agents, from the simplest to the most advanced. It's a fascinating journey through the levels of artificial intelligence. So let's get started. Let's imagine we're building a smart home system that can automatically adjust the lighting and temperature. To make this happen, we're going to use AI agents. But wait, before we start coding, we need to figure out what kind of AI agents would work best for this job. That's where this video comes in. It is all about understanding the different types of AI agents so you can pick the right one for the task. First, we have a simple reflex agent. Picture this. You're baking cookies and you set your oven to 350 degrees Fahrenheit. But then you open the oven door and the heat immediately drops to 325 degrees. Why? Well, because a simple reflex agent doesn't consider the impact of opening the oven door on the temperature. It only reacts to the current state. So when the door opens, it thinks the temperature is too high and tries to lower it. But it doesn't realize that opening the door is the reason for the higher temperature in the first place. For this agent, it's just an if-then situation. If oven door is closed, set temperature to 350 degrees. If oven door is open, set temperature to 325 degrees. This agent is great for tasks where the environment is well understood and predictable, like controlling the temperature in an empty room. However, it's not perfect for complex or unpredictable environments. Now let's look at a model-based reflex agent. Unlike its simpler sibling, this agent keeps track of past experiences and uses that knowledge to inform its decisions. It builds a model of the world and updates it based on new information. So back to our oven example. With a model-based reflex agent, after opening the oven door several times, it would learn that the door's position affects the temperature reading. It could even predict what would happen if you opened the door again without adjusting the temperature setting. Model-based reflex agents are useful in situations where the environment is partially hidden or not fully observable. Like imagine you're designing a self-driving car that needs to navigate through traffic. A model-based reflex agent would be able to use its knowledge of traffic patterns and road conditions to make better decisions than a simple reflex agent. Next on the list, we have goal-based agents. They take things a step further by setting goals and planning actions to achieve those goals. Instead of simply reacting to the current state of the environment, goal-based agents consider the future consequences of their actions and select the best path to achieve their desired outcome. For example, a goal-based agent could be designed to help you lose weight. It could set goals such as exercising 3 times a week and eating 2,000 calories per day. It would then plan actions to achieve those goals, such as scheduling workouts and suggesting healthy meals. Unlike previous agents, goal-based agents are more proactive. They can perform actions without being explicitly told to do so. For instance, they could check the weather forecast and plan a bike ride for later in the day if the weather is nice. But wait, there's more. Goal-based agents can also handle changes to their goals. For example, if you tell your agent to find the shortest route to work, but you notice that traffic is heavy, you can change your goal to finding the fastest route instead. The agent will then replan its actions accordingly. The ability to adapt to changing circumstances makes goal-based agents incredibly versatile. Now let's talk about utility-based agents. These agents take an even more sophisticated approach to decision-making by assigning numerical values or utilities to different states of the world and actions. They aim to maximize the overall utility and make decisions based on the expected utility of possible actions. For example, a utility-based agent could be used to manage a portfolio of investments. The agent would assign utilities to different investment strategies and select the strategy with the highest expected utility. If the stock market is volatile, the agent might choose to invest in safer assets to minimize risk. On the other hand, if the market is steady, it might opt for riskier investments to maximize potential profits. What sets utility-based agents apart is their ability to handle uncertainty. They can analyze probabilities and make decisions based on the most likely outcomes, rather than just relying on current observations. This makes them valuable in situations where not all information is immediately available. Finally, we have learning agents. These supercharged AI agents can learn from their experiences and improve their performance over time. They have the remarkable ability to adapt to new situations and refine their decision-making process based on feedback. One way learning agents can improve is by keeping track of their past experiences and using those experiences to inform future decisions. This is called a learning element. For example, a learning agent could keep track of which stocks have performed well in the past and use that information to inform its investment decisions in the future. Another key component of a learning agent is the ability to evaluate its performance. This is handled by the performance element, which compares the agent's actions to a desired behavior and provides feedback for improvement. For example, the performance element of a self-driving car might compare the car's driving behavior to that of a human driver and provide feedback on how to improve. Learning agents also have a critic that evaluates the quality of the agent's performance element. By providing feedback to the learning element, the critic helps the agent improve its overall performance. Additionally, learning agents often have a problem generator that creates new situations for the agent to learn from. This is particularly useful in situations where the agent cannot learn from real-world experience, such as playing games or simulating environments. Overall, learning agents are the most advanced type of agent, as they can continuously learn and improve their behavior. However, they also have the potential to learn negative behaviors or overfit to the training data. Therefore, it's essential to carefully design the learning process and evaluation metrics to ensure that the agent learns positive and generalizable behaviors. Choosing the right type of agent depends on the specific task and environment. Simple reflex agents are suitable for tasks with clear if-then rules, while learning agents excel in complex adaptive environments. In our smart home example, a simple reflex agent could control the temperature, but a learning agent could optimize energy usage by considering factors like time of day and weather. Remember, there's no one-size-fits-all solution. The choice depends on your needs. If you found this video helpful, please give it a thumbs up. And don't forget to subscribe to our channel for more exciting content. Also, make sure to check out our website. Thank you for watching, and see you in the next video.